Another important question related to voltage source versus current source is that which one we prefer to use at our home. Before we answer this question, we need to there is fundamental understanding of how we connect the load in the houses, because as we know now we can connect them in series or we can connect them in parallel, but we only connect them in parallel for one simple reason. For example, if I want to remove this load from the circuit, nothing will happen from the other circuit and they will still receive the required current. But if we connect them in series, if I disconnect, for example, this from the circuit, the whole circuit is interrupted and every single other load will not receive any current. So we connect the circuits in parallel. This is to start with as a fundamental information. Now, let's compare between connecting the loads in parallel using a voltage source or connecting them in parallel using a current source. So here we have only two exactly the same loads connected in parallel with these little switches to say that we connect them on or off. So let's start if we connect only one load, one resistance. So here for this one, we have only one resistance. So this is not connected. This is the only one connected. And the current in the circuit using Ohm's law is the 10 volt divided by the 1K, which is 10 milliamps. And this I1 will be this 10 milliamps. And in this circuit here, we have exactly this. So we have one resistor connected. And here the current is around 10 milliamps. We have the 10 voltage and we have only one resistance. The other one, it's not yet connected. Now, when we go to the current source, the current source will provide us with a constant current, okay? So the current is 10 milliamps, will be going through the resistance, okay? And will cause a voltage. And this voltage will be equal to this 10 milliamps times this 1K, so it is 10 volt. So you can see that both cases are exactly the same, have the same current delivered at the same voltage. Now, watch what will happen if I connect another resistance in parallel. So we'll do that first practically here. So I will come here, I will come and just connect the other resistance and watch the current. What happened to the current? The current doubled. The current doubled. Which current that doubled? The main current. This current. This current doubled because I'm measuring this current. So what does this mean? It means that this I1 will stay as 10 milliamps and I have another 10 milliamps coming from this. These two are added using KCL and I will have here the 20 milliamps, but every load has the same voltage, which is the 10 volt, because they are connected in parallel, and the same current. So nothing happened to the first load, no interruption. However, if we go to the current source, let's see what will happen here. Now, this current, the 10 milliamps, will come and we'll see two equal resistors, so it will be split. This will have 5 milliamps and this will be having 5 milliamps. So the current reduced to half. Not that only, but also the voltage has been reduced because the voltage here becomes equal to 5 milliamps times 1K, so it is 5 volt and 5 volt. So both the voltage and the current for each of those two loads has been reduced. This is why we prefer to connect or to use a voltage source over a current source.